Solving for one variable. So when we're solving an equation like this, we're trying to solve for a single missing quantity. So we're trying to find the value for x that makes the equation true. So for example, if somebody said, well, x is 10, well, that wouldn't work because 10 plus 6 would be 16, and that is not the case. So some of these you're able to kind of work out in your head. For example, you might look at this and say, oh, well, 4 plus 6 is 10, and that's awesome. And I don't want to discourage you from doing that because that's using intuition and that's solving a puzzle. That's great. But at certain points, this will start to get a little bit more complicated. We'll have decimals, fractions, things that are a little less intuitive and less obvious. So something that I want you to have in mind are what we call inverse operations. Just simply opposite operations, operations that undo one another. So for example, addition and subtraction undo one another. Multiplication and division undo one another. And another good one would be exponents, like x squared, and square roots undo one another as well. So these are some examples of inverse operations. So let's start with this first one. So you might look at this and already know, but we're going to solve this with inverse operations. So I like to draw a T-chart here. It goes right through my equal sign. And I'm going to decide that I want to get all of my x values on the left, all of my constants on the right. So currently, and if you don't know what a constant is, it's a number that does not have a variable. So currently, all my x's are over here, which is good, but this 6 is also over here, and it needs to be with the constants. Now, to cancel out a positive 6, I would want to use my inverse operation and subtract 6. Now, to keep an equation balanced, you have to do the same thing on each side. So I would also subtract 6 from the constant here. So these 6's will cancel to 0. That's great because now I just have an x over here, which would equal 4. Again, do I want you to solve those intuitively just by looking at them? Totally. But I also want you to understand this process. Okay, the next one we have 3x plus 4 equals 13. So again, I'm going to draw my table. And I'm going to decide, I'm going to get all my x's over here. It doesn't really matter which side, but I'm going to get them all over here because it's already over here. It's already an x over here. And all of my constants over here. So looking over here on the left side, I see there are some things that are not x's. Okay. Now, this coefficient, this number that is attached to my variable, I'm going to deal with that at the very end. Okay, that's a little easier to deal with that way. So I'm going to start with this plus 4. How can I get rid of that plus 4? Well, I can subtract 4. And remember, I want to keep the equation nice and balanced, so I'm going to subtract on this side as well. So these 4's will cancel, and over here I'm left with 3x equals 9. So really what this is, yes, we read it as 3x equals 9, but it's 3 times x equals 9. 3 times something equals 9. So we have multiplication here. I also have a 3 that is not where I want it. I only want x's over here. So what is going to undo multiplication? Division. So I'm going to divide both sides by 3, thus making these 3's cancel out. 9 divided by 3 is 3, so I have that x equals 3. All right, this next one I'm going to rewrite over here because I used a little more room. So again, I will put my little key chart in here. I want all my x's on this side, all my constants over here. So remember, I'm going to deal with that 2 that's attached to the x there, that coefficient. I'm going to deal with that last. Let's start with negative 9. Well, if I subtract 9 here, I'm going to get negative 18, and that's not going to get me any closer to where I need to be. I'd still have a negative 18 over here. So I need to use my inverse operation. What's the opposite of negative 9? Well, it is plus or positive 9. Minus 9 is the opposite of plus 9. I'm going to do that on both sides. These 9s cancel out. I am left with 2x is equal to 16. Or 2 times something equals 16. Now again, to undo my multiplication, I'm going to do division. The 2's cancel out. 16 divided by 2 is 8, so x equals 8. Cool. We're going to do this one on a later video.